All right, good morning and welcome back to statistics. So yesterday, the previous video, we were talking about confidence intervals regarding proportions. And today we're going to continue our discussion on that. I'll show you how to do a couple of problems, but for the most part, this is a pretty straightforward sort of an exercise here. Okay, so here we go. Go ahead and share the screen here. And let's just get started with working on this. All right, so according to the U.S. Census Bureau, 33% of men who worked at home were college graduates. In a sample of 474 women who worked at home, 155 are college graduates. Okay, so what our first idea here is we're going to say X is equal to 155, and my N is going to be 474. All right, so what they're going to say is find a point estimate. I should have done this first. Sorry. Find a point estimate for the proportion of college graduates among women who work from home. Okay, around the answer to 3 decimal places. Okay. So what we're going to do, pop that in. We'll say 155 divided by 474. Done. Okay, that was 0.327. Okay, so 155 divided by 474, this was 0.327. Okay, there we go. All right, so we're going to type this in, 0.327. Okay, how many decimal places do they want? 3. Okay. All right. Construct an 80% confidence interval for the proportion of women who work at home and are college graduates. Okay, so what we're going to do is we're going to go to our calculators and we're going to say stat tests. We want to go to one sample Z proportion. Okay, 2 samples, that's if we have to compare, right? If we're comparing two sample things in these particular things. Usually this happens like a before and after sort of a thing. Okay, but what we care about right now, one proportion is the interval. Okay. And we're just going to type in the values. Okay, we have 155 for X. Okay, we have 474 for Y. And then we want what kind of a confidence interval? 0.80. Okay, and then we're just going to calculate. Okay. So what did we get? We got, I'm going to put this over here. So we got 0.2993, 0.35462. Okay, and they said 3 decimal places, so this is what I want. Okay, this 3 doesn't contribute, so this is going to be 0.299. And then 3 decimal places, this 6 will contribute to that, so it's going to be 0.355. Okay, so somewhere between 30, close to 30% to 35.5%. Okay, so if I was going to tell this to a human being, right, my proportion would be 29.9% or 35.5%. Okay, that's what we'd probably say. All right, so let's go ahead and put that in. So we want 0.299, 0.299. Okay, and then for the other one, we have 0.327, 0.327. Nope, sorry, 0.355. Okay, check our answer. Okay, excellent. Based on this confidence interval, is it reasonable to believe that the proportion of college graduates among women who work at home is the same as the proportion of college graduates who work among men? Okay, so what is the proportion of men? It's 33%. What is the proportion of women? It's 35.5%. Okay, that's the upper bound. So does this 33 fit into my confidence interval? Like, yeah, it does. So my statistics vision, I can't tell the difference between 30 and 35%. Okay, so all of these, since this is inside of it, like that's all we can say is like, well, it's inside. I don't have any evidence to say that it's different than. So we're going to say Yep, it's the same. Okay. Let's see. Is it reasonable to believe the proportion of college graduates among women is the same as? Yes, because 0.33 is within my confidence interval. Okay. And we should be okay there. All right. So that's the kind of question I would ask. This would be a very standard, straightforward kind of this would be a question you could expect to see on a quiz. All right. It's very straightforward. Let's see here. Sleep apnea is a disorder in which there are pauses during sleep. People with this condition frequently wake up to breathe. In a sample of 433 people over 65, 107 of them had sleep apnea. All right, let's have a look. All right, so my next thing down here. So we have 107 was my X. Okay, do you have sleep apnea? Yes. So that's my X divided by how many people did you ask? I asked 433 of them. So this is my N. Okay, so X over N, that's our point estimate. Okay. 107 divided by 433. Let's see, what do they want? 3 decimal places, and we want find a point estimate. Okay, 3 decimal places. So 0.247. Okay, so this is 0.247. 0.247. All right, check answer. Beautiful. 99.5% confidence interval. Okay, that's what they want. 99.7%. So we're going to go to stat tests. We want 1 proportion Z interval. 1 proportion Z interval. Okay, enter that in. What do we have here? We have 107. We had 433 people. What kind of confidence interval do we want? Okay, that's 99.5, so 0.995. Calculate, enter. All right, and there's our so you notice they gave us a point estimate in here anyway. So if we knew what part 2 was, we wouldn't have needed to calculate part 1 independently. Okay, but that's okay. Okay, so 3 decimal places here. Let's do this. It can be taught. So this is 0.1889. This 9 is going to go and help that 8 out. So it's going to be 0.189. Okay, so somewhere close to 19%. Okay, 18.9%. And what's the top one is 0.3053. This 3 is not going to contribute, so this is going to be 0.305. Right? And that should be our set. Okay. In another study, medical research concluded that more than 11% of elderly people have sleep apnea. Okay. Based on your confidence interval, does it appear that more than 11% of people age 65 or older have sleep apnea? Explain. Okay. So I'm not asking you about sleep apnea. I just want to know about the numbers here. Look at this proportion, right? It's about 0.1889. Okay, so about 19-ish%, and we're going up to 30.5%. All those numbers are bigger than 11. Okay, this is all bigger than 11% or 0.11. Okay, so what we're going to say here is since all the values of the confidence interval rate are larger than the 0.11, okay, everything here is bigger than the 0.11. We could claim that does not contradict the term, because we just said more than, okay, and our confidence interval supports between 19 and 30, 30.5, so that is more than 11. Okay, so they say more than 11, okay, that sounds good to me. All right, and we'll go on after that. All right, so let's see here. General social survey asked 1,309 people. Okay, 1,309 people. if they performed any volunteer work during the past year. Okay. We'll go ahead and look. Actually, let's skip the volunteer work one because it's a very similar problem to what we just did for the sleep apnea. Right. I'll go over number 7 only because I've asked this one on a quiz before. Okay, but if it's effectively the same problem, but I'm likely to ask it again. Okay, so we have n, right, is 41, x is equal to 28. Okay, so we're looking for, we have 28 of these sites had detectable levels of lead. Okay, and we took a total of 41 samples. Okay. Part A, construct a 99% confidence interval for the proportion of specimens that contain detectable levels of lead. So we're going to go over here. We're going to hit our stat tests, 1 proportion z test, 1 proportion z interval rather. Enter. So what are we looking for? We're saying that we had 28 total. Okay. There was 41 possible. It's going to be about 3/4. And then they went 0.99. Okay, and now we're going to hit calculate. All right, 1 proportion z interval. So we have a proportion somewhere between 0.49573 and 0.8701. So what decimal places do they want? 3 decimal places. All right. So 3 decimal places. This 7 is going to contribute, so it's 0.496. This 0, this 1 isn't going to have anything to say, so 0.870. So somewhere between almost 50% and 87%. Right? So we're going to be saying something like 0.49. What's going on? Okay, so we're going to say 496 to 0.870. 0.87. I do that, but it's going to yell at me. Okay. Check. See, I didn't like that. You don't have to put the 0 there. Like, yeah. Okay, construct a 95% confidence interval. So let's go through the same deal. So stat, tests. I want 1 proportion z test. That one, sorry. Okay. Oh, no, I don't. Calc. Do I want tests? 1 proportion. I want 1 proportion z interval. I don't want a test. I want a z interval. 1 proportion z interval. Sorry about that. So 21, right? Let's see here. 28 out of 41, but instead of a 99% confidence interval, I want a 95% confidence interval. All right. Calculate. By the way, if you were the construction manager here, these levels would be mandated by law. The EPA would have something to say about, well, you have to do a 95% confidence interval, or whatever they would want. That's what we're going to do. Okay, because you can manipulate your confidence intervals to get the answers you want, and that's not an appropriate way to go. All right. So we'll type those 2 in. So great. Again, they don't like trailing 0. Whatever. What is the effect of increasing the level of confidence? Well, going from like a 95 to a 99, what happens to the interval? Right? We're going from 0.54% to 0.9496. So 54% to 50%. And then we're going from 82.5% to 87%. Okay. So this got wider. right? Made the thing wider. That's what I'm saying. That you have to mandate this stuff by law. Otherwise, people will like choose whatever confidence interval gives them the right answer so that they can do what they want. So that's why we have a standard. All right. So great. All right. That was what, number 7? Yeah, I'm unlikely to ask you. I know what this problem is going to do. I'm unlikely to ask you for this problem. But yeah, let's go ahead and take a look at it. So we have a total of 206 people. 39 of them have changed jobs. Okay, let's write that down. So our X is equal to 39. Our N is equal to how many people total did we interview? We said 206 people. All right. So let's see here. Construct a 95% confidence interval for those who have changed jobs in the computer industry for the past 6 months. Okay. So we're going to go stat. 1 proportion z no. 1 proportion z interval is what I want. There we go. 1 proportion z interval. Enter. Okay. All right. We have 39 out of total of 206. All right. And they want 95% confidence. Great. Enter. Okay. So there it is. Okay, we have our point estimate. Okay, 0.1893, about 19%, 18.93%. And then here is our confidence interval. So this is, how many decimals do you want? 3 decimal places. So 0.135, this 8 is going to contribute a little bit. So it's going to be 0.136. All right. And then this 8 is going to help that 2 there. So it's 0.2428. This 2 is going to help, this 8 is going to help that 2. So it's going to be 0.243. So 0.243. All right. And check our answer. Right, great. And then it says among the 206 people, 124 of them were under the age of 25. All right. So this one is going to be a little bit weird. So we started with a total of 206. Okay, and then they said of them, 124 are under age 35. All right. So we're going to say that constitutes a random sample of workers under 35. So we're going to say these 124 is a random sample. Okay. If this sample were to be used to construct a 95% confidence interval for the proportion of workers under 35 who change jobs, it is likely that the margin of error would be bigger, smaller, or about the same. Okay, so we are going, so my first N, okay, so N in part A was 206. N in part B is saying we have 124. Okay. So that's what we're doing with this. I get this is a little bit difficult to kind of put together. All right. If this sample were to use to construct a 95% confidence interval for the proportion of workers under the age of 35, so we don't know what the X is, right? I have no idea how many of these people were under the age of 35. Don't know. Okay, but we are going to now use 124 instead of 206. All right. So we started off. Okay, let me do the formula for us. So we have p hat plus or minus z square root p hat 1 minus p hat over n. Okay. So in this case, n is equal to 206. We have p hat plus or minus z square root of a different p hat. So we'll put little subscripts here. We'll say 1, and this will be the second part. Divided by, actually, let's put this in. So let's say this is 124, and we'll say that the other one is 206. Because the only thing that changed was those 206. Okay, we'll assume everything else was the same. Okay. And they want to know what's happening to your margin of error. What is happening to this whole thing? Is it getting to be if I go from 206 to 124, is it going to be a bigger number or a smaller number? Okay. So don't worry about the rest of all of this stuff in here. Okay, we're just going to worry about like what is the effect of having fewer people in our sample. So one way to think about it is like if I have fewer people in the sample, I have to account for more variability. So my margin of error should go up. Okay. Now, let's make an easy example instead of doing it this way. This is about double, right? 206, 124, and that's not quite double. But if I have a fraction, right, and I divide it by 12, or if I have that same fraction and I divide it by 6, okay, like if I'm going to take my pizza and turn it and cut it into 12 pieces, right, each piece is going to be a little bit smaller, okay, so this piece here is going to be a little bit smaller. But if I have my pizza and I cut it into 6 pieces, right, those are going to be like sometimes ridiculously large pieces of pizza. Okay, so that's going to go a bit bigger. Okay, so my margin of error should be a bigger number. Okay, the margin of error will be larger because the sample size is smaller. Okay, you know, you could also like type in everything exactly the same and just change those 206 to 124 and see what happens. Okay, so if you're like, I doubt you're telling me the truth. That's fair. Type them in, okay, with exactly the same things, except that use 124 instead. So, well, how do I get my P? Like, well, what did we have here? My proportion was what was my proportion? Okay, P hat is about 19%. So what we're going to do is we're going to say N over P was equal to 0.19. I'm sorry, X over N. What am I thinking? X over N was about 0.19. We have to solve for N. So we're going to say that this is N is equal to X over 0.19. Okay, do it that way. All right, so we could get what our proportion is supposed to be. All right, to get this answer. Yeah. All right, but so yeah, you can check me on that one. Okay, or you can just type in like it was about 95 or 19%. You see what happens. We don't care about these actual numbers. You could just say, well, 19 for my P, and then just use 100 and see if the number got bigger or smaller. Okay, so we'll check and be okay. Hooray! All right. I'm unlikely to ask you a question like this because I know dealing with this fraction in this question can be a little rough for a lot of people. I also can't tell if you were clever and typed in a number and used it that way instead. So I don't know. Okay. So there is our homework for this piece. Okay, I think that's it. So we'll close the book on confidence intervals. All right. And we'll be done with that. All right. Until next time.